Lead 2 oxide. This Roman numeral 2 indicates the charge on the lead is +2. So if we were going to do crisscross or cross and drop, lead has a 2+ charge, oxygen has a 2- charge. Cross and drop or crisscross, those numbers come down, Pb2O2, but we reduce to the lowest common multiplier. So if we divide both of those by 2, we get PbO. Lead 4 oxide. The 4 tells us the charge on the lead is +4. Oxygen is still -2. Crisscross or cross and drop, we have Pb2O4 reduced to the lowest common multiplier. Divide both by 2, we get PbO2. So this is your grade 9-10 crisscross or cross and drop rule. The premise behind the zero-sum rule is that a compound has a net charge of 0. That's because the total positives in the compound equal the total negatives. So when we do the zero-sum rule, for lead 2 oxide, we know that the lead is +2. We know that the oxygen is -2. These add together to give us 0 already. So the formula is 1 of both. They add up, the total positive equals the total negative. So we just don't need any subscripts. If we do lead 4 oxide, so we separate the positive and the negative. This is +4. This is -2. The +4 and the -2 are not equal. If you add them together, you do not get 0. To get 0, if we multiply -2 by 2, we end up with a -4 charge. Whatever number you multiply by becomes your subscript. So this formula is PbO2. You'll notice that you don't have to divide by any common multiplier for this. It just straight up gives you the formula. Here we have a compound containing tin and oxygen. Tin is a multivalent, so we've got to figure out which valency tin has. What is the charge on the tin? So if we were doing crisscross, we would have to do reverse crisscross. So the subscripts cross over and come up. So that would mean we've got tin and oxygen. Tin would be 2, and the oxygen would be 1, because we don't write our 1s, it's just understood. But this is not true. Oxygen does not have a charge of -1. It has a charge of -2. So we would have to multiply both the negative and the positive by 2. So this would be tin 4 oxide, which gets a little bit messy. So this is tin 4 oxide. You have to remember to double check your valencies when you do a multivalent metal. It does work if you have an atom, a metal, or a positive ion that has only one possible charge. If we were going to do this using the zero-sum rule, Here's our formula. So we've got our negatives. We know that oxygen is -2. There happens to be 2 of them, so we multiply by 2. So the total negative is -4. That means, because it's zero sum, that the total positive should be +4. We divide it by the number of atoms. Here you can see there's only 1 tin, so if we divide it by 1, that means our tin has a charge of +4. So tin, 4, oxide. There's no need to double check anything. Do a couple more examples using zero sum. Copper and chloride form a compound. So we need to figure out what the charge is on the copper. So we break it into positive and negative. Well, chlorine has a charge of -1 in ionic compounds. There happens to be 2 of them. So we multiply the negative charge by 2, so we get a total negative of -2. That means the total positive must be +2. We divide it by the number of atoms of copper, of which there's only 1, and that tells us the charge on that copper. So here we've got copper, 2 chloride. Here's another one. We've got a compound containing iron and sulfur. Break it down into the positive and negative. We know that sulfur has a charge of -2. There's 3 of them because it's S3, so we're going to multiply by 3. So the total negative is -6. So the total positive must be +6. Now in this case, we've got 2 atoms of iron. So we have to divide by 2, divide the total positive by 2, so that gives us +3. So each iron is +3.